MVC, MVP, and MVVM are three of the most widely used architectural patterns in software development, and they are also three of the most commonly confused. By the end of this video, you will know exactly what each one does, how they differ from each other, and how to choose the right one for your situation. Imagine a function that listens for a button click, validates the input, calls an API, formats the result, and then directly updates the DOM, all in one place. That is the problem. The UI and the logic are tangled, so you cannot test one without the other, and changing one risks breaking the other. MVC, MVP, and MVVM all exist to pull those concerns apart, but they each draw the boundary in a slightly different place. Think of a restaurant. The diner is the view. They see the menu and receive the finished plate. The chef is the model. They hold all the recipes and do the actual cooking. The difference between MVC, MVP, and MVVM is really about the waiter in the middle, how much work the waiter does, and whether the chef is ever allowed to speak directly to the diner. That single question is where the three patterns diverge. Here is a quick map of each pattern before we see code. In MVC, the controller receives user input, updates the model, and the model can notify the view directly. The view and model are aware of each other. In MVP, a presenter sits in the middle and does everything. The view is a dumb interface that only exposes methods. In MVVM, the view declaratively binds to a view model's observable properties, so updates flow automatically without any explicit wiring code. We start with a shared counter model, whose only job is to hold a value and increment it. In MVC, the MVC controller receives the onIncrement call, tells the model to increment, then manually calls view.render. The controller reaches out to both sides. In MVP, the MVP presenter looks almost identical, but the key difference is that the view is defined as a narrow interface, making it completely passive and easily mockable in tests. In MVVM, there is no view interface at all. Instead, the counter view model exposes a subscribe method. The view registers a listener once, and every future increment automatically notifies every subscriber. The view never has to ask for an update. The sharpest difference is coupling. In MVC, the model is allowed to notify the view directly, which keeps the controller slim, but ties the view to the model's event system. That makes the view harder to test in isolation. MVP breaks that link by routing every interaction through the presenter, so the view becomes a plain interface you can mock in a unit test with 2 lines of code. MVVM takes it one step further and removes the manual notification calls entirely through data binding, but that convenience requires a reactive runtime, something like RxJS, Angular, or Vue to be in place. The choice usually follows the platform. MVC is a natural fit for server-side frameworks like Express or ASP.NET, where a request comes in, a controller processes it, and a template renders the response. There is no persistent UI state to bind. MVP shines in environments where you want to test every pixel of behavior without a screen, such as Android or desktop GUI frameworks. MVVM is the dominant choice in modern front-end development. Angular, Vue, and similar frameworks are built around reactive binding, so the view model pattern slots in naturally. If your environment does not provide reactivity, MVVM's main advantage disappears. All three patterns share one goal: keep your business logic away from your UI code. MVC does that with a controller that sits between input and the model, while letting the model talk back to the view. MVP tightens that by making the view completely passive and routing everything through a presenter. MVVM goes further still, replacing explicit method calls with declarative bindings, so the framework handles synchronization for you. The pattern you choose depends on your platform, your testing needs, and whether you have a reactive runtime available.